morning. This will be C7, Principles of Reinforced Concrete Design, and we will start with our learning module 1. So this will cover flexural analysis in reinforced rectangular concrete beams. Okay, so first, for our reinforced concrete materials, we have, of course, concrete. Is defined as a composite material that consists essentially the binding medium within which are embedded particles or fragments and aggregates. And for our definitions, we have the definitions of plain concrete, reinforced concrete, and pre-stressed concrete. So our main concern here is this one, reinforced concrete. Now, so reinforced concrete. Then, yung iba, hindi naman importante yan. So, you have to study that. And to make it short, we have here the properties of concrete. May vary dito sa following. The selection of type and quality of materials, varying mixed proportions, the use of admixtures, varying methods of mixing, conveying and placing, and the curing method. So, should take it up in your construction materials. Okay. Now, for our materials, actually, since reinforced concrete actually is composite member, because actually, so for example, we have a beam, this beam. So that beam cross-section will have dimension B and H, for example. Then we provide reinforcing steel designated as AS. And actually, this is important, yung effective depth D. Now, bakit nasabing composite siya? Kasi nga, concrete and steel. So, yung isa is concrete. Then, the other one is steel. So, steel. Okay. Ngayon, bakit siya tinawag na reinforced concrete? Kasi nga, yung concrete, nilagyan rin steel para i-reinforce siya. For the purpose that yung concrete kasi, magaling sa tension yan, ay sa compression. Good in compression. But in tension, weak tension siya. Weak tension. Whereas for steel, both in compression and tension, malakas siya. So, kumbaga, itong tension na ito, bale ang ginagawa natin yan is neglected yung effect na yan. Neglected yung effect. So, we have to neglect ito. Okay. Now, this strength of concrete is defined by its compressive strength, FC prime. Ayan, yung FC prime. Okay, FC prime, which is actually the compressive strength of concrete. Now, compressive strength of concrete usually based on 28 days. 28 days. Okay. So the factors affecting FC prime will be the material characteristics, the stage, of course, there are some other factors. Now for steel, dito yung steel. The strength of steel is defined by its yield strength Fy. Fy And actually, the designation should be with letter FY. And also we have yung FU. FU. Okay. Now, here in RCD, before we start with our main lecture, kailangan mo nating malaman yung behavior ng cognitive loads and some other concepts, important topics to be taken up before we start with the design or analysis, especially itong mga term nito. For example, we have the water cement ratio. So yung water cement ratio determines the strength. Okay, kumbaga in our dialect, pag kasi yung sa concrete, meron ka rin kailangan i-consider din yung workability niya, then yung strength. Okay. The lower the water cement ratio, the higher the strength. Kaya lang, hindi siya workable, no? Okay. Kaya kailangan proportion diyan. And meron siyang certain value, range value of water cement ratio in structural member. Okay. So I will just discuss this behavior of concrete under uniaxial compression. So when we have a concrete subject to compression, from about 0 to 0.30% or 0.30 of FC prime, the linear, the behavior of concrete is linearly elastic. Linearly elastic, and there will be micro cracks in the transition zone wherein it is undisturbed. From 0.30 to 0.50, so micro cracks extends due to stress concentration of crack tips, and crack propagation is stable, still stable. No cracking occurs in the hydrated cement paste, and additional load distributed across the interface is having a gradual change in the stress time drop, wherein sigma is greater or equal to 0.40% of FC prime. And from 0.50 to around 0.75 of FC prime, localized hydrated cement paste cracks develop parallel to the compressive load during the transverse tensile strain. Transition zone cracks continuously growing, and the stress approaches around 0.75. There is a bridging of mortar and transition zone cracks. System becomes unstable. So kanina, stable. Saan yan? Dito sa 0.30 to 0.50, stable yung cracks. But if it reaches 0.75 of FC prime, stable na siya. So magkakaroon na siya ng crack. Okay, now for the behavior of concrete later on, I will discuss yung sa I think third part here of this module. So I will discuss the behavior of concrete, of reinforced concrete to loading. Importante yan para maintindihan nyo kung ano talaga yung RCD. Okay. So then next we have the modulus of elasticity of concrete. So meron tayong tinatawag na normal weight concrete at saka yung lightweight concrete. So yung value dito, so we have the in English and we have in SI. So we have the modulus of elasticity of concrete is 4,700 square root of FC prime. Okay, so actually paano makukuha yung 4,700? So if you are going to divide 57,000 by 12, you will get 4,750 na. So pwede siyang gamitin yan as conversion factor na. So divide lang ng 12. Okay, nakukuha na yan yung SI unit. Then we have for weight of concrete na 90 to 150 PCF. The modulus of elasticity is given as W 1 raised to 1.5, 33 discard of FC prime, that is for English, and W raised to 1.5. So if you divide 33 by 12, that is around 0.043 FC prime. Okay, so yan. Ngayon, due to the evolution of code, no? So kasi dito actually, ang code na gagamitin natin is ACI, that is the American Concrete Institute. American Concrete Institute. Okay. Now, dito sa Philippines, we are using a National Structural Code of the Philippines. So, meron tayong 2001, merong 2010, then merong 2015. Ayan. Okay. So, ngayon, dito muna tayo mag-start sa 2001, then yung 2010 and 2015, ihabol natin. But actually, yung mga problems na bibigay ko as activity or problem sets, you are going to solve it with 2015 code. So, medyo problema yan naman kasi 2001 puro ko tapos 2015 yung problem. So, kaya na, bahala na yan. Okay. So, modulus of elasticity of concrete, 4,700 square root of FC prime. The next is we have the modulus of rupture of concrete. So, modulus of rupture, FR, is equal to 0.70 square root of FC prime. So, in English system, that is 7.5. Divide mo ng 12, that's around 0.70. And I have a table here showing the modulus of elasticity of concrete for different FC prime from 17 to 42 megapascal, and we have here the value. So, ibig sabihin, nagbabari na. Okay. That's usually, kaya nga dito tayo nagkaroon dito ng value eh. So, the modulus of rupture is dependent of its compressive strength. Yan lang ang ibig sabihin niya. Then it is stress strain curve. This is for concrete. So makikita niya, we have the concrete strain against the compressive strength, PSI. So we have 0 to 5,000. Then we have strain of 0.001 to 0.0035. So depende sa strength niya eh. So 1,000, 2,000. So ito yung naging curve niya. Yung curve niya. So pagdating dito sa strain around 0.02, kung makikita niya, something around 0.02, yung concrete nagkakaroon ng change in the behavior, and that's why makikita niyo itong concrete strain na 0.002 na yan. Later on sa value ng phi, makikita niyo yan, no? Yung 0.002. Okay, sorry, that is not strain, but that is not phi, that is strain in concrete. 0.002, not this one. 0.002, especially in the NACB 2000. And by the way, for solving fee, kailangan natin yan. Okay, so ito ngayon yung strain compressive strength curve. Okay, so ito we have behavior concrete under multi-axial loading. Okay, sabihin lang natin ito dito. So kapag yung concrete natin, for example, we have a cylinder, it is subject to full compression on both sides. So it's increased strength, delay propagation of cracks, thereby delay failure. Okay, ngayon kapag subject to tension lahat, walang effect. The strength is the same, no significant effect. But if it is compressed and subject to tension on the lateral, it reduces both tensile and compressive strength. Okay, so medyo important ito, significant ito kasi mag-reduce yung both the tensile and the compressive strength of concrete. Unlike here, ito subject to tension lahat, walang pagbabago, walang effect. Dito naman na-increase yung strength. Okay. So kasi yung concrete talaga is best in compression, in tension weak, very weak. Okay. Okay, so this effective confinement, dagdag ko na lang yan pag dating natin ng column. No? Sa column, kung ano ibig sabihin ng confinement, hindi niya pa maintindihan ngayon. Okay. So, basta ang importante dyan, alam niyo yung dalawang type ng column. Tinatawag na tied column at saka spiral. Spiral column. Okay. So, pag titingnan nyo, kumbaga, pag tied column, rectangular or square siya. Tapos pag spiral, circular, hindi. Actually, hindi yan. Kasi pwede namang maging spiral kahit na rectangular. Okay. Pagdating natin sa column, saka ko na lang i-explain yan. Basta at least meron kayo ng iniisip na, tied column, rectangular yung bilog, spiral. Okay. Now, these are the other change in behavior of concrete. So we have shrinkage. This is shortening of concrete during hardening or drying. Primary type is drying shrinkage, such as loss of absorbed water, and depends primarily on relative humidity, but also on cement content and water cement ratio. Again, andito na naman yung word na water cement ratio. Okay, isa malaking issue sa atin yan, sa reinforced concrete. Okay. So then we have here second form of shrinkage, carbonation shrinkage, and ito yung creep. Itong creep naman is type of deformation due to sustained loads. Ibig sabihin yung loads na hindi natin nahalos, sustain siya for how many years, then magkakaroon ng cracks yung concrete. Ang tawag natin doon is creep. Pag nag-crack siya due to drying of or loss of absorbed water, shrinkage yan. Siyempre, mainit, di ba? So, just take note muna, the total strain is total strain due to shrinkage and creep will be equal to elastic strain plus creep strain plus shrinkage strain. Okay, hindi naman masyado importante ito dito sa atin, but in construction materials actually dapat pag-aralan yan. The point is, wala tayong gaano gamit na yung mga equipments to do the test. Okay. Okay, so that is for concrete. Ngayon, meron pa tayong ibang pwedeng factors regarding concrete. So, bigyan ko naman kayo ng mga references din na magbasa-basa din kayo. No? Magbasa-basa din kayo para talagang matuto kayo. Use textbooks. Kahit naka-English, important din magbasa tayo. Then, sa steel, may tayo yung round bars, and ito naman yung mga designations niya. So, yan ano, American grade ito. So, yan. I would explain this when we take up actually wala tayong laboratory pala ngayon kasi yung C7 walang laboratory, although samahan pa rin natin. So in laboratory we'll discuss 2015 code, kaya doon kasi next time I will tell you kung anong kailangan yung gawin na. So meron tayong mga strengths, 40 to 50 KSI, we have 60 KSI and 75. Ito high grade ito. High grade usually ito sa sobrang taas ng strength niya, hindi natin gaano ginagamit sa reinforced concrete. Ito na grade 60, mas okay ito. Grade 60, especially pag mga high-rise, itong 40 to 50 sa mga medium-rise building. Actually, meron tayong 33 KSI. Yun yung mga andito. Yung mga andyan sa local market natin. No? Actually, importante dapat alam niya pag nag-design tayo, alam natin kung ano talaga yung andun na gagamitin. Kasi halimbawa, nag-design ka, ang ginamit mong grade is 40 KSI. No, 40 KSI ang ginamit mo sa design. Ngayon, ginamitan ng 33 KSI sa pag-construct. Malaking problema yan. Kasi dapat magkakaroon ng adjustment sa design. Okay. So, meron tayong, ito yung main rib. Then we have the initial producing mill, yung nag-manufacture. Then yung bar size number, steel type, any type of deformation. Okay. So, meron tayong 1 line and 2 lines. Kapag high grade, 75, 2 lines, Ito yan. Ito at saka ito. Tapos pag 1 line lang, brag, grade 60. Ngayon, pa grade 40 to 50, wala siya. Natural na ito dito. Yung ganyan. Meron dyan, natural na yan. Pero itong additional line, so dito wala. Dito 1 line, then dito yung 2 lines. Okay. Then we also have another one. Ito, another type. So, ito yung mga ordinary grades na tinatawag. Ngayon ito, since galing ito sa textbook, hindi eksakto yung mga diameter. So, actually ito, this is approximately ito yung mga 10 mm diameter. Ito yung 12. Ito yung 16 mm, 20, and so on and so forth. No? So, actually, after 20, meron ng 22, then 25, 28. Actually, merong 30. Ewan ko lang kung bakit wala dito. 30, merong 32. Okay, and so on. So, usually, dito tayo sa range dito. Ito, saan ito ginagamit na 10 and 12? Usually, pang stirrups, o kaya sa stabs. Ito namang 16 to 30, usually sa mga beams, columns, yan ang ginagamit natin. So, dito yung mga bar number nila. Kapag tinignan nyo sa mga textbooks, may problem, sabi, bar number 10, 2 peraso, ibig sabihin 10 mm yan. So, this is now the nominal area, and we have here the mass. Okay. Importante dito itong mass kasi sometimes substandard yung rebar, sabihin sa'yo 12 mm, okay, 129 nga yung area niyan, pero pag nag-cut ka ng 1 meter at kinama yung weight, baka hindi siya pumasok sa 0.994, no? Yun yung mga substandard. Okay. Then we have the deformed hot rolled reinforcing bars, mga mayroon yung required number na yung ASTM. Ano yung ASTM? American Society for Testing Material. Okay, testing material. Napapansin niyo, meron tayo ACI. ACI, tapos meron ASTM. Ano ba to? For American. So actually, yan kasi yung kinuna natin ng NCP. Pagdating sa NCP, dyan meron na dyan ng sa concrete, meron ng sa RCD, meron ng sa steel, meron sa timber. So, pinaghalo-halo na sila. Diyan na. May mga pagbabago pero hindi lang ganun karami. So, meron tayo grades 40, grade 60, grade 75. Ang ibig sabihin niya, grade 40, that is 40 KSI strength, 60 KSI, and 75. So, bakit wala dito yung 33? Okay, kasi totoo lang, pangit gamitin itong 33. Kasi mahina. No? Yan bakit yan ang ginagamit dito? Mostly makikita sa hardware. Siyempre, mura. Tapos, sabihin nila grade 40. So, katayo na ma-adjust at marunong tayo. Okay. Sabi dito, note, grade 75 is not allowed in seismic structures. Okay, usually we design medium rise to high rise. Siyempre, palaging meron tayong, ano ba yung basis natin dyan? Live loads, dead loads, and earthquake loads, wind load. So, yan. So, kapag merong earthquake loads, kailangan yung ductile na material. So, hindi tayo gumagamit ng 75. So, at least hanggang 60. This is for high rise, sinabi kanina. For medium rise, ito grade 40 and grade 33. Okay naman. Ito grade 40. Pwede na masabi na ito yung maganda. Ito naman grade 60. Pwedeng hindi available in market dito sa atin. Pero sa mainland, Ito, usually ito yung ginagamit, grade 60. Okay. So, by the way, yung grade 40 is ranging from size number 3 to 18, then size 3 to 6 for grade 60, then size 6 to 18, with maximum FU of 70 KSI 19,100. Okay. So, dun sa textbooks na bibigay ko sa iyo, may naman dun ng mga conversion factors. So, you can convert English to SI. Oh, makita nyo talaga, hindi yung puro lang SI na kaagad. Hindi na alam tuloy yung English. Actually, dyan yung basis, and dyan galing. Okay. Oh. Okay. So we have the grade of ASTM reinforcing steel bars. Okay. Basahin nyo na lang yan. Then we have the stress strain curve for steel. Okay. Discuss natin ito. So kung makikita nyo dyan, nakalagay yung mga FY, although this is in English, so meron tayong 40, 50, 16, 75. Makikita nyo yung stress strain diagram niya. Ito yung for 40 KSI, ayan, 40 KSI. So kung makikita nyo, andito siya sa may 40 kasi nga yan yung yield strength niya, no? So kung 40 yan at saka 60 ito sa gitna, ibig sabihin 50 yan. Diba? So kung makikita nyo, habang nagiging mataas yung grade niya, yung dito sa strain side, hindi siya umaabot dito sa bandang dulo, na? Pero ito na grade 40 to 60, makikita nyo yun. Ito yung mga niya, yung stress strain curve. Then yung niya, yung ductility kasi makikita mo yung ductility niya. Yung sabihin, fracture yielding, meron pa siyang strain hardening at saka yung, di ba, yung necking. Yan, actually sa strain of materials, so meron tayong mga properties na importante yung balikan. Actually for steel kasi, so this is the stress strain curve ba, meron kayong makikita ganyan, take up strength of materials. Yan yung stress strain diagram niya. Ito is elastic dito, elastic. One is plastic. So plastic, actually perfectly plastic eh. Okay, so pag ganyan yung stress strain diagram na, natawag natin yung material na is elastoplastic material. Elastoplastic. Elastoplastic. Okay, so sana naalala niyo pa na yung mga key points natin dyan. We have yield point, we have the elastic limit, we have the proportional limit, meron tayo ng strain hardening, then we have necking, modulus of rupture, or like FU, and we have FY. Okay, so napaka-importante dito yung value ng FY. That is actually yung yield strength niya. Yield strength of steel. At saka yung FU din. FU. Okay, so importante yan. Dito sa RCD, mostly itong FY. Pag si steel design, yung FU and FY. Importante yan din. Okay. Sabi ito for high-rise building, grade 60 is recommended. Okay. By the way, the modulus of elasticity of steel in English is around 29,000 KSI. 29,000. Okay? Anyway, 29,000. 29,000 KSI. $29,000 KSI. And in okay, 29,000 KSI and 200,000 in SI. So always use 200,000. always use 200,000 megapascal and SI units. Okay. Ito naman yung sa welding, ano? Mga electrode designation, E70XX, E90XX, E100XX. That is compatible dito sa mga grades na ito dito sa welding. Okay. Now, ito na yung lesson number 2. Lesson number 2, but I think we have to stop the video first and we will take this up in the next video.